Hi guys, long time without an update. It's been a long time since I've updated you guys, but that doesn't mean that I haven't been 3D printing. In fact, I've been doing a lot of it over the last couple months and working on a pretty neat project that I want to share with you. So this video is kind of an introduction to a 4-part series that I want to release, and I'll describe to you exactly what my intent is with these coming videos. Most of you, or some of you, know that besides 3D printing, my other passionate hobby is scuba diving. Those of you who follow me on Twitter know that I'm Jim Scuba 2386. But I've been scuba diving since 1997, and I do recreational diving, I do dry suit cold water diving, I do cavern diving, I do technical diving. It's the other thing that sucks up all my money, and it's what I really enjoy doing. And as I've gotten more into it, you acquire more gear and you get more tools. And one of those tools is a cave light, an underwater cave light. This is very important for technical diving and recreational diving to a degree that not only is it for seeing in the dark and dark wrecks, dark caves, things like that, but it's also a signaling device. I think I'll probably show a video right here are some pictures of how that's used. One thing this light comes with in this pack is this battery here, which is beefy. It is a nickel metal hydride battery. It is 20 smaller batteries put end to end, 2 sets of 10 in parallel. So I've been using this since 2010, and the battery has finally given up the ghost. It will not charge anymore. So I went and called the company and said, hey, I need a new battery. What's that going to cost me? And they told me $555 for the battery. And I said, well, the light is, at the time was $1,300, so it's almost half the price of the light for a battery. A bit expensive. I said, well, that's always an option. I can pay $555 and get the battery replaced. But this seems like a job for 3D printing. So batteries are in parallel, well, 10 in series and then 2 sets in parallel. So 20 batteries. They're soldered end to end, and you can't take them apart. I mean, you can desolder them, but they're permanently soldered together, which makes it hard to change the batteries. So I said, can I make a new battery pack where I can take this battery pack apart, take each battery out individually, put it back together if I need to, and use it. It's permanent but semi-permanent. You can take it apart, replace the batteries, no big deal, just in case one goes bad or you need to get to one. And I said, we'll see what we can do. So this is the essence of the design project. It's a very good project. Basically, the battery has to fit in the container. That's a constraint. The battery is very tightly packed in the container, so I need to make a design where the new design fits within the envelope of the old battery, and it's got to have parts that are batteries that are removable and replaceable on the spot. So can it be done, and how do you do it? So this is where my intro to the next coming videos comes in. I thought it would be useful that, even though probably not a lot of people who follow me are technical scuba divers and could care less about actually making the battery pack, I thought maybe I'd take you through the design process and the way I attempted to solve the problem, acknowledging that there's many ways to solve a problem, but I know I've heard from lots of people, how do you start? What's the thought process? How do you move in the direction of solving a problem from seeing the problem to getting a final result? That's where these next videos are going to come from. I'm expecting 4 videos, depending on how long they go each. It could be video 1A and 1B. I split it up a little bit, but the general breakdown of the videos are going to be video number 1 is fusion modeling of the existing battery. So how do we go about modeling this battery in Fusion, where my goal is to not watch me design the entire battery, however, show you things like sketch, extrude, pattern, construction planes, importing existing parts from McMaster Carr, the basic concepts I use to design the battery, and show you maybe how to build a section, because once you can build a section, you can build the whole thing. So just to give you some Fusion 360 basics, admitting that I am not a master of it, but I know enough to be dangerous. Video 2 is going to be coming up with a new design that fits within the envelope. So step 1 is design the battery pack so we know what size we're working with. Step 2 is how do we design the parts to fit within that envelope. So that'll be designing the new parts into CAD. And again, not showing you the entire design process, which took me 1 to 2 weeks, but show you the skills and the functions that I used to design it all and my thought process to get from point A to point B. Video 3 is assembling the new design. So print the parts out and show some of the maker skills I use to put the design together. This might be basic to some people, but maybe some people haven't seen it before. Ideas that I have: drilling and tapping, heat insert contacts, 3D printing jigs and assembly fixtures, locating pins, gluing, just basic stuff like that. Nothing too crazy. I might throw in a little bit of lathe, but just some basics, more on the assembly process and why I did it the way I did it and the order of operations to get it done. Video 4 is design testing, failure, and failure analysis. So I'll tell you right now, my buddy and I both have these lights, and I've already built one of them. I've been working on it for a couple months. We built it, we ran into some issues, and I said, okay, can we fix them? And this would be an opportunity to show people that, hey, if you go into Fusion 360 and use finite element analysis, you could have predicted that this failure would have happened and how to use it to redesign the product to make it better. So this is my opportunity to show you a very basic FEA analysis in Fusion 360 to help you predict whether your models are good or bad or how to optimize them. So that's my goal. In the end, like I said, I don't expect anybody to make one, but my hope is that you'll see the thought process from beginning to end on how I attack the problem. Not saying that it's the only way or it's the best way, but maybe that will get some people thinking about how to go about a design process from beginning to end. So I will be filming these videos over the next couple weeks. Don't freak out if my shirts change color mid-video, because I have a feeling what's going to happen because of the assembly process and everything. I'm going to film when I have time, so I might have 10 minutes here, 20 minutes the next day, an hour the next day. So I may jump around a little bit in the videos, but my goal is to get these out in the next week or two, and hopefully we'll find the design process fairly interesting. So stay tuned for that. I'll start working on the first video once the kids go to bed. So stay tuned for that. Hope you enjoy it, and talk to you soon.